I'd like to have a real quick surface overview of what goes into wiring a house. Really quick. Let's just zoom through these. I want to hit some high points. First of all, you hear people talk about a service entrance. What that means is where the power from the overhead or underground line comes into your house, where it connects to the meter, where it enters, that's the service entry. And it can be wires overhead or it can be wires underground. Grounding is super important, and it is regulated by the National Electrical Code, including grounding in a service panel. So when you see these boxes, these panels, in olden days they had fuses in them, now they have breakers in them, circuit breakers. What was my point? So this is called the service panel, and there are strips in it called buses, and a bus is just a strip of copper, strip of metal, to which other wires connect. It's like an efficient way of wiring things. There are some requirements about wire color, particularly the ground. The ground has to be green if it's not bare. The hot wire is black, and if you see a white wire, that's a neutral. And your electrician will determine what size of service panel you need based on how many amps are required in your house. It's a typical size to see 200 amps. I think I've seen some small houses with 125. So the wires come in off the pole, and as you know, I think we talked about 120 and 240 volt. I'm going to skip over that though, because I want to talk about branch circuits just real quickly. From your service panel, you get wires splitting up in different directions, and those are branch circuits. And the National Electrical Code has things to say about branch circuits, including, let's say a lighting circuit in your living room, or an appliance circuit in your kitchen, or some other circuits for your 240 volt stuff. And the electrical code has rules about how big the wire has to be. It also has rules about how many amps each circuit has to be. So your electrician cannot just wire up one big old long loop of wire through the whole house. He or she has to add up how many amps will your appliances and lights draw in a particular room, and he or she has to stop at 15 amps for a lighting circuit or 20 amps for a small appliance circuit. And you're required to have 20 amp circuits in the kitchen because you have microwaves and coffee makers and blenders and all kinds of stuff that draw more amps, so you need a bigger capacity. You are also required to have GFCIs, which stands for Ground Fault Circuit Interrupter, and you have to have those any place there's water. So that means your kitchen, your bathroom, your garage, and your outdoor outlets. A GFCI, you've seen them in bathrooms, they look like this, and they automatically cut out whenever there's a break in the circuit. They're faster than a circuit breaker. Then you have to have some other stuff like fans in an enclosed room that has water, and light fixtures certain places. And when your electrician is wiring up the outlets, the convenience outlets, that's what these are symbols for, those are outlets, they follow the 2-6-12 rule, which comes straight out of the electrical code. 2-6-12 means every wall more than 2 feet long has to have an outlet. An outlet you can't have an outlet any more than 6 feet away from any door or opening in the wall. So you see some dimensions here, no more than 6 feet. And then between outlets, you can't be any more than 12 feet apart from outlet to outlet. And there are some other rules for kitchens. You will go into old houses sometimes and see outlets that are way farther apart than 12 feet and farther away from the door than 6 feet, and that's no longer code. Here's what outlets look like. Actually, technically speaking, the outlet is the place where the junction box comes to the wall. It's an outlet of the wiring system. And then these things with prong holes in them are actually called receptacles. There are several kinds of switches that you will draw, and two-way switches. A two-way switch is just a switch that has two wires. So here's a switch connected to a light bulb, 2 wires and a switch. A three-way switch has 3 wires, and a three-way switch is what you see in a room where there's one switch on one wall, one switch on the other wall, and a light in the middle. That is a three-way switch because there are 3 wires. And the way you draw it on your drawing is you make the letter S for switch, and then you put a number 3 for three-way. Then finally, the electricity comes to the job site first temporarily, then the electrician does some rough-in with the Romex wire and the junction boxes and so forth. That comes right after the framing happens, and then they will add the fixtures, the receptacles, the lighting fixtures, and so forth. So the framing goes up, then the rough-in wiring goes.